Okay, today we are going to discuss outer measure. So outer measure is actually if we have any subset of R, then we denote outer measure by this absolute notation, which is nothing but we take the infimum of the sum of the length of open intervals ik such that A is contained in these open intervals. So we take the infimum of the length of we take the infimum of the sum of the length of the open interval whose union contains the set A. So now we have property number one. Property is if A is countable, then outer measure is 0. So to prove that, since A is countable, so we can say that let A is actually xk. Okay, since it is countable, so it can be countably infinite or countably finite. So we will assume that okay, let A is equal to x1, x2, x3, x4 up to so on. Now let epsilon greater than to be 0. Why? Because actually we are going to have open intervals, okay, for each element of A. So definitely then we say that for each k we have ik is actually the center is the element xk minus epsilon divided by 2k plus 1 and xk plus epsilon divided by 2k plus 1. Now definitely every element of A will belong to one of these open intervals ik. Okay, so then if each element of A belongs to one of those open intervals, so this means that definitely the whole set will contain in the union of all these open intervals. Okay, this implies that. Now what can we say about the outer measure of A? Since it is the infimum of the sum of the length of the open intervals, so now definitely we can clearly see that the outer measure or infimum is less than or equal to sum of the length of the open intervals. Now what is the sum of the length of the open interval? If we can see, then clearly it is epsilon divided by 2k. Okay, so now what is this series is geometric. This series is geometric and the sum is epsilon. So from here we can say that A is less than or equal to epsilon. Now epsilon is a positive number and the outer measure itself is positive. So this inequality clearly tell us that the outer measure itself is then 0. So here we show that okay, that the outer measure of a countable set is 0. How? Strategy was, first for each element of A we define open interval ik, and then clearly every element of k will belong to one of those open interval. So this means the whole set A will contain in the union of those open interval, and then since we know that the outer measure will be is infimum, so infimum of the sum of length of open interval is less than the sum of length of open interval, and then we have the open interval, and we can length is actually length of this open interval is, so length of this open interval is nothing but b minus a, so which is epsilon divided by 2k, and then the sum is geometric, the series is geometric, and the sum is epsilon, and from there we got the idea that okay, the outer measure is 0. So we actually just use the definition of the outer measure, and that's it. Now the second property is that if E is a subset of R, then the outer measure after E plus T is nothing but this is outer E, where T belongs to real number. Okay, so proof. We need to prove two things. Number one is that out since these are two numbers, so to prove that the two numbers are zero, we will show that the first number is less than the and a second number, and the second number is less than the first number. So e plus t is less than e, and second is e is less than e plus t. Okay, this is easy to show that. We will see that. Okay. So now for fun, so for one, okay, we will say that let E is contained in union of Kik. Then clearly E plus T is also contained in union of Kik plus T. Clearly, okay. So now what can we say about the outer measure of E plus T? Since it is the infimum of the sum of the length of the Ik, so definitely then the outer measure of E plus T will be less than the sum of the length of the Ik plus T. Now what is the length of Ik plus T? Clearly it is actually, this is nothing but this is the length of Ik itself. Okay, so now what is now, so this is actually E plus T. Okay, this is less than sum of K length of Ik. Now if we take the infimum, now if we take the infimum on both sides, okay, if we take the infimum over this sum, and also we know that the set E is actually contained in the union of K, so from there if we take infimum, okay, then clearly we can say that E plus T, the outer measure of E plus T is less than the outer measure of E. So that's we proved. Now from this one we will prove the second one. Okay, for second, for 2, which was what, which was E is less than E plus, so the second one was E plus T. This was the second one, right? Okay, so then if you want to show this thing, from 1 we have actually from 1 we have E plus T is less than E. Okay, so now how can we write this E? So I can write this E, okay, is nothing but this is E plus T and minus T, right? Now if we see here this thing, so then this implies that E plus T, hence the outer measure of E is less than the outer measure of E plus T. Thus E plus T, the outer measure of E plus T is the outer measure of the city. I hope you understand this thing. And now the third property is actually, if A is a subset of B, then outer measure of A is less than outer measure of B. Okay, so for proof, clearly it is very easy. Since A is contained in B, so we will say that let B is contained in union of Kik. Then since A is contained in B and B is contained in union of Ik, so this means that So clearly, A is also contained in union of Kik. Now, thus, then the outer measure of A is less than or equal to sum of K is equal to 1 to infinity length of Ik. Because A is the infimum, the outer measure is infimum, and the infimum is less than the sum of the length of the open interval. Now, if we take infimum, okay, so now if we take infimum over all sequences of open intervals whose union contains B, then clearly the outer measure of A is less than the outer measure of B. Hence, the outer measure of A is less than B. And this property is called monotonicity. Monotonicity, which is very important. Everywhere we use it. That if A is contained in B, then the outer measure of A is less than the outer measure of B. I hope you